Alright, chapter 7 is all about exponents. Let's review what exponents are. Remember, there are two parts in an exponent. So if we have something like this does not mean 2 times 3. It means that I have 3 2's. So the answer to this problem would be 2 times 2. That'll give us 4. And then if we multiply it by 2 again, we should get 8. And there's 2 parts to our exponent. It has this big number down here at the bottom, and we call this the base. And then this little number up top, this tells us how many times we are multiplying our base together. And this can be called our exponent, or a power, but they both kind of mean the same thing. So we can do this with either numbers or variables, but it all works out the same. So if we had something like y to the 5th power, our base is y, and our power is 5. So that means I want to multiply 5 y's together. So it would look like y times y times y times y times y. So now that we know that, let's go over some things that people tend to mix up, make sure that we're all on the same page, and then we're going to learn some rules about exponents. We're going to learn multiplication rules first. So just to make sure that everybody can do some evaluating. Evaluate doesn't mean solve. There's going to be no equal sign here, but just simplify this. Tell me what the number value is. Value is hidden in the word evaluate. So problem number 1, start off with something easy, 6 squared. If I tell you to evaluate that, that means tell me what 6 squared is. Means that I have 6 times 6 multiplying together, and we know that that's 36. Chances are you have that one memorized, but we can do that for absolutely any number we want, and we can type it in our calculator, and it'll give us the answer out. Ones that people always mess up are ones with negative signs. So if we give a problem like this, what this means is that I have 2 negative 5's being multiplied together. So negative 5 times negative 5. This gives me positive 25. Your calculator will also tell you that, but you have to make sure that you type those parentheses in. Because if you type it in like this, or if you're given a problem like this, it's a totally different answer. This problem says that I have negative 5 squared. What this means is that I have the opposite of 5, so like negative 1 times 5 squared. The only thing being squared is this 5. By putting it in parentheses up here on this one, that tells us that the whole thing, the negative and the 5, are being squared. So for this one, I have negative 1 times 5 times 5. So you can see for this one we would end up with negative 25. So make sure that if you are typing it into your calculator, that you type it in with parentheses if your problem gives you parentheses. So now that we have re-gone over that, let's talk about the first rule that we need to for exponents. So we have a couple multiplication rules that we're going to learn first, and then a couple division rules that we're going to learn, and then we're going to put them in problems all together. So for each one of these rules, I'm going to prove why the rule works, and then give you what the actual rule is. But the awesome thing about these is if you ever forget, it's really easy to reprove it to yourself what the rule is. So let's say I gave you something like x to the 4th times x cubed. What the first part means, the x to the 4th, means that I have 4 x's, all multiplied together. And then this part, the x cubed, means that I have 3 x's, all multiplied together. And I'm multiplying the 4 and the 3 together. So it's very easy to see I have 7 x's. So is there a way to get 7 without going through and writing down the 4 and then the 3? Well, obviously we can see if we add 4 and 3, we end up with 7. So rule number 1. Rule number 1 says that if your bases are the same, so if you notice both of these had an x, that's the only reason we can combine them. If your bases are the same, let's say we have x to the n power and x to the m power, two different numbers, that we can combine these by adding our exponents. Next multiplication rule that we are going to do is very similar to this, and it's easy to get these two confused. So we're going to learn a couple of these rules, and then we're just going to do some problems with them all together. So the next rule, let's say that I have x squared all cubed. If we think about our exponent rules that we know, this means that I have 3 x squareds. This on the outside, so that I have x squared times x squared times x squared. And we can remember the rule that we just learned, that if you have the same base, you could add all those together, or we could go one step further if we also forgot that rule. This means that I have x times x times x times x times x times x. So all together here, we end up with 6 x's. So how can we get 6 without writing all this stuff out? Well, if we go back up here and look at these two numbers, we have 2 and 3. We can multiply those together to end up with that 6. So rule number 2. And again, your bases need to be the same. If they're not the same, you cannot do any of these rules that we're going to learn. So for this one, the base, there's only one base there, so obviously when we factor it all out, it's going to be the same. But when you have a power to a power, so let's say I have x to the n power, and I take that to the m power, we can multiply those two together. So obviously it's very easy to get this one confused with this one that we just did. So when do you add, when do you multiply? The thing that I remember is there's some distance in between these numbers right here, where here the numbers are really close together and they're separated by a parenthesis. So normally parentheses mean multiplication. That's how I remember it. When you come down here, parentheses mean multiplication, you multiply those guys together. With this one, there's some space in between, so that says do something else, don't multiply them together. So last multiplication rule that we need to do, and then we'll do some problems with these. Last multiplication rule is kind of almost like a distribution property. So let's say that I have x times y, and it's all to the 4th power. What that means is I have xy times xy times xy times xy. And we know that multiplication is commutative. That means I can switch things around. So really, I can rewrite this as x times x times x times x, because I had 4 of them from here. And then it's y times y times y times y, because I had 4 here. And then what we really have, if I write x times x times x times x, is x to the 4th. And then I have the same amount of y's. So what we really did is said, I want 4 x's and 4 y's. We kind of distributed that exponent. So here is our last multiplication rule. Rule number 3. So rule number 3 says that if I have two things, let's say A and B, and they're multiplying, they must be multiplying in here. If they're adding or subtracting, this rule does not work. So if they're multiplying and they are taken to some power, it's the same thing as A to that power times B to that power. And this would work if I had A, B, and C all inside of here. Whatever you have inside the parentheses, you can distribute that n to. So now that we know our 3 rules, let's do some problems. Start off with some easier ones. Let's say that I have w cubed times w to the 4th. Well, I look, the bases are the same. This means I have 3 w's, this means I have 4 w's, so I would end up with 3 plus 4, or 7 w's. Let's do another one. Say I have m to the 4th power. I want to take that to the 2nd power. So we need to remember our rule says that if they're separated by just a parenthesis here, we need to multiply those 2 together. So 4 times 2 will give me m to the 8th power. Let's do one with rule number 3 that we just got done doing. Let's say that I have x squared times x cubed, all in parentheses. And I want to take it to the 4th power. There's a couple different ways that we could approach this problem. The first thing I could do is distribute that 4 to both of those things there. Or I could take a look inside my parentheses. There's something to simplify there first. And remember, simplify parentheses before you do anything else. So 2 and 3 inside of here, what do I need to do with them? Since they are multiplying, I want to use the rule that says I have to add those together. So on the inside, I end up with x to the 5th, all to the 4th power. So 5 times 4 will give me x to the 20th. Let's do one more weird one. Problem number 4. Let's say in parentheses I have 5x squared, y to the 7th, to the 3rd power. So first thing I want to do, just like the last problem, is make sure that there is nothing inside of those parentheses that I can simplify. I have 3 different bases. I have a base of 5, a base of x, and a base of y. Can't do anything with those, so now I have to resort to distributing this 3 in. And the only reason I can distribute it is because all of these things are multiplying in here. So I get 5 to the 3rd power. Remember, this isn't 5 times 3. And then I have x squared to the 3rd power. And then I have y to the 7th to the 3rd power. So now I need to simplify these. We don't want to leave it like this. It still looks messy. 5 cubed, remember, is 5 times 5 times 5. You can type that in your calculator, or you could do it in your head. 5 times 5 will give me 25. Multiply it by 5 again, I end up with 125. And then we have x squared to the 3rd power. That means total we have 6 x's. And then we have y to the 7th cubed. So I have 3 groups of y to the 7th power, and that gives me 21 y's. And that's it. We can't simplify, we can't combine anything because the bases are the same, so we're done. And that is the end of our multiplication rules.